Hey, it's Coach Stapleton here, and today's lesson will be on Lewis dot structures and how to place the valence electrons around the symbol to create a Lewis dot structure. And an example of a Lewis dot structure would be this right up here. Okay, so chlorine, and the number of dots is equal to the number of valence electrons that element has. So to do these, you need a little review of valence electrons. This goes back to chemistry A. This is an example right here of nitrogen. Nitrogen, the atomic number is 7. So nitrogen would have 7 protons, and because there's not a charge given here, nitrogen would also have 7 electrons. When we do the Lewis dots, it's sort of like a Bohr model of the atom like we did first semester, except we're only putting the dots down for the electrons that are in the outer shell. So if you look at this Bohr model right here, nitrogen again has 7 electrons. According to the Niels Bohr model, 2 electrons would go into the first energy level, and the first energy level is the one closest to the nucleus. And then if we use 2, we have 5 electrons left. So 1, 2, 3, 4, 5 electrons in the outer shell. And those electrons in the outer shell are called valence electrons. Now, you don't have to do the Bohr model to determine the number of valence electrons. You can determine the number of valence electrons just by looking at the periodic table. So on this slide right here, I've actually labeled the number of valence electrons for you in each group. And you can see in group 1 or family 1, all of those elements have 1 valence electron. These numbers that I wrote up here with the pen are the number of valence electrons in those groups. So sodium, although sodium has 11 total electrons, sodium would have 1 outer shell or 1 valence electron. If we go over here, just sulfur, you can just go to the top of that group, and the number that is written is the number of valence electrons. And again, when we do these Lewis dot structures today, we are only taking the number of valence electrons, and those are the dots that go around the symbol. So chlorine was already done for you on the first page. Chlorine's in group 17. And if you go above that, that tells you that chlorine would have 7 valence electrons. So going back to the first page, here's chlorine. If we're doing the Lewis dot structures, we're only putting the valence electrons around the symbol. So chlorine, according to the periodic table, has 7. And here's the 7 dots around chlorine. 1, 2, 3, 4, 5, 6, 7. So this is what the final product will look like when you guys do these at home, but I'll show you the method to getting the electrons to pair up the way they're supposed to pair up, and that'll be important in later lessons. Today we're just starting easy, just starting with the Lewis dot diagram for a single element or a single symbol. Okay, so when you do this at home on your own, you will actually get this sheet right here. I have a couple of homework sheets for you, and you should be able to put the dots around these symbols and then share it back to me in the Google Classroom. So you will do the following Lewis dot structures. I'll probably switch up the symbols a little bit because I'm going to do a couple as an example for you, and you will do it just like I'm going to show you in a few minutes. Okay, so the first one here is nitrogen. So again, we've got to figure out how many valence electrons nitrogen has. So you can do that by either going to the dynamic periodic table. Nitrogen's in group 15. So I know, because I've memorized it, that if the elements are found in group 15, they will have 5 valence electrons. But if you don't want to memorize those, you can go back to this periodic table. Nitrogen's right here. And then the number that has the arrow pointing down to the group is the number of valence electrons. So nitrogen has 5. So your assignment then would be to put the dots around nitrogen. When you put the dots around the symbol, And I like to use the brush for this because the dots are larger. But when you put the dots around the symbol, I always tell the students, I always tell them to go around clockwise, hitting the corners of the clock first. So 1 o'clock or noon, sorry, let me say that again. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. And then you can start pairing them up. So again, nitrogen has 5 valence electrons. We're going to put it around nitrogen. So 1, 2, 3, 4, and then you can start pairing them up. 5. And then these are actually coming out pretty light. So you can use the marker too, but it just gets a little messier when you try to fill them in. But it'll show you where these dots are. And I will be able to see if you want to use the paintbrush. I'll be able to see them. They're just a little light for you guys to see right now. So again, because there's 5 valence electrons, I went around the clock first. 1, 2, 3, 4, and then pair it up with 5. Okay, so let's do fluorine. Fluorine would have how many valence electrons? Yep, fluorine has 7. So I'm going to go back to the paintbrush, and I'll do it in red this time. So 7 valence electrons go around the clock first and then pair up. 1, 2, 3, 4, 5, 6, 7. And then what you're going to find when we get to the next step, when we do ionic bonding and ionic compounds with Lewis dots, is that these single electrons here can either be transferred or shared. Okay, so you have 7 around there. And again, I know this isn't showing up very bright with the paintbrush here, but you should be able to see the 7 around. Okay, I'll do one more for you, and that would be sodium. Sodium has 1 valence electron. So I'll change the color again, see if I can get something a little darker. I'll go back to black. So sodium has 1 valence electron, so it would just go right there, the 1 dot. And we'll do one more that has more than 1. So oxygen. Oxygen, find it on the periodic table. Oxygen has 6 valence electrons. So if I'm putting the dots around, go around the clock. 1, 2, 3, 4, 5, and 6. And then once you do that, later on when we get to the next lesson, we'll start asking how many paired shares there are, or shared pairs there are, and how many unshared electrons there are, or how many singles. So this one has 1, 2, 3, 4, 5, 6. So when I share this with you, I'll change the symbols a little bit, but you will put the dots around the symbol in the correct spot. Okay, the other thing that you guys will have to do is this sheet right here. There's 2 pages to it. So you are just putting the group or family number, the number of valence electrons, and then doing the Lewis dot structure. So here's calcium done for you. And what I did, I'll do carbon for you, but I took sticky notes from this Jamboard here and just placed the sticky notes inside here. So carbon here is found in group 14. That's this number right here. It tells you. Carbon is found in group 14, and it has 4 valence electrons. So I'll do carbon for you as an example. Carbon is, and here's the sticky notes, group 14 and 4 valence electrons. So I'm just going to make sticky notes for those. And then I am going to pull it down, group 14, 4 valence electrons. And then you can do a sticky note for the symbol too. oops, sticky note for the symbol. So the symbol is C. And then because it's 4 valence electrons, I'm going to put 4 dots around it. So let's do this. The paintbrush, 4 dots. 1, go around the clock. 2, 3, 4. And there actually might be a way to be able to make these darker. I'll look that up. So when you guys are doing it on your Jamboard yourself, there might be a way to make these paint marks darker. Okay, and then that's it for that. So you would do the next ones, hydrogen, helium. The only exception here is helium. I'm going to tell you this right now. If you look at helium, helium's over here in group 18, but helium's right here in group 18, so you would think it has 8 valence electrons, but helium only has 2 electrons total, and it only has 1 shell or 1 orbital, so that's a full outer shell with 2, because the first one can only hold 2. So helium is found over here, but it only has 2 electrons, so it only have 2 dots for the electron dots, or the Lewis dots. Okay, a couple more things. I will also share with you guys this wakelet right here, and you might have to sign up. You can sign up with your Google account, but this wakelet right here has a lot of different videos on drawing Lewis dots. Some of them are more complex than what we've done yet. But if you look at drawing just the Lewis dot diagrams right here, this first one, I'll share this with you in the Google Classroom also. This one right here, this will go through drawing the Lewis dots for you also. And then all of the assignments that we might get to during this time, during this unit, is also pasted on this wakelet board right here. So if you have time, you can look through that a little bit. And then the last thing is I'll attach this to the Jamboard. Obviously, you guys at Fruitport know my email, but if you're watching this on YouTube and you're a teacher from another district, you can email me or check out my Weebly. It has a lot of the assignments on it also. And then also the wakelet is made public. So if you're a chemistry teacher and you would like to look at some of the stuff I shared on the wakelet, again, that's this right here. There's assignments, there's videos, there's labs that the students can do. But again, because of being on this quarantine for the 2020 school year, spring 2020 school year, I'm posting all of this on here for my students to use. But if you're a teacher from another district, you can use that stuff also. So that's about it. I will, for the students at Fruitport, set up a Zoom meeting. Sometime you'll get an email or something in the Google Classroom about that. So if you do have other questions about how to draw the Lewis dot structures, you can look at that and join me on a Zoom, and I'll answer some of their questions that you guys might have. Okay, so that's it for the intro to the basic Lewis dot structures of around an individual image.